See where we left off yesterday. We talked about forget that. I'll just do it like this, and like this, and like this. And we just kind of touched base a little bit on what we're going to do here. Remember we said if we use this angle right here, you can call it any angle. I'll tell you what, let's just call it theta, just to get used to that. That's how I like to start off putting the theta in there, just so you get used to seeing it. So if I said uh, give me another ordered. What do you call that? Triple thing. What do they call that? Pythagorean triple.
3, 6, 5.
3, 4, 5. But give me another one. Wasn't there another one like 5,
6, 8,
7?
10.
Was it 5, 17, 24? Was that one?
I got it.
Or 5, 12, 13? I think it's 5, 12, 13. Is that what it is? 5, 12, 13. Right. So if that's 5, that's 12, that's 13. Okay. So if I asked you, let's just do this quick. This is just kind of a quick review of yesterday, and we'll move on from this a little bit. So if I asked you what the sine of theta was, what would you tell me? Okay, it's opposite over hypotenuse. You remember the little thing, right? Little mnemonic device. You ever hear that word?
13.
Okay, so it's what? So, toa. Did you say that in the hallway yet? Nobody said it? Oh, you guys, come on, play along. All right, so anyways, so the sine is opposite over hypotenuse. Opposite of what? Opposite of the angle right here, okay? I could have another angle up here, couldn't I? But I'm talking about this angle right here. And so the sine, tell you what, instead of, went through that theta thing, but let's,
45.
no, not going to put any numbers in there. Okay, we'll just call this ABC. All right, so if I said, what is the sine of angle A? All right, if I said, what's the sine of angle A, it'd be the opposite over the hypotenuse, and it would be what? 12 over 13. And if I said, let's find the cosine of angle A, the cosine is the adjacent over the hypotenuse. So if we're talking about this angle right here, angle A, the adjacent is what? 5 over the hypotenuse, which is 13. The hypotenuse doesn't change, does it? It's always going to be the hypotenuse. And what if I asked you to find the tangent of that angle? The tangent is the opposite over the adjacent. Opposite over adjacent. So that would be 12 over 5. Everybody with me on that? All right, so let's continue. What if I went up to angle B? And this time I'm going to refer to angle B. So the sine of angle B, it's still opposite over hypotenuse, but now my opposite is different than it was when I was at A. So now it's 5 over 13. Agreed? And then, let's just go in order. The cosine is adjacent over hypotenuse. Adjacent to this angle right here. What side's adjacent? 12 is. Now, technically, 13 is technically adjacent to angle B, isn't it? Both of these sides are adjacent. But 13 happens to be the what? Hypotenuse. And that kind of supersedes the adjacent thing, right? If it's hypotenuse, it's hypotenuse. So we're talking about the adjacent side, right? Or the adjacent leg, if you want to call it. These are the two sides or legs of the right triangle. So if I did cosine, it's adjacent over hypotenuse, which is 12 over 13. Everybody with me? And then you've got the tangent of angle B. So up here at angle B, the tangent is opposite over adjacent. So opposite over adjacent, that'd be 5 over 12. If you look at this, do you see any resemblance to some of these? Look at this. Look at this 12 over 13. Well, you kind of see 12 over 13 right here. So look, the sine of A is the same exact thing as the cosine of B. All right, that's right. And look at this. The cosine of A, 5 over 13, is the same as the sine of B. All right, and the tangents are just reciprocals of each other, aren't they? So the tangent of A and the tangent of B are reciprocals. So that's kind of interesting, isn't it? See a little relationship between there, and sometimes that's going to help you out later on. I just wanted to point that out to you. All right, so we know what the sine, cosine, and tangent of each of these angles are, but who cares? I mean, who cares what the sine of the angle is? Well, we care because what that's going to do, it's going to actually allow us to find what that angle is actually equal to. So, you know all these things, and I'm going to get rid of them. They're still on your homework, or on your notes, if you took notes on this. So, what if I just said find or solve? I think, do they say find or solve? What do they say?
Find.
They say find? Okay, so find angle A, the measure of angle A, they might say, something like that.
Yeah.
All right. So find the measure of angle A. So how in the world do we do that? Well, look, I've got, and let's do this. Let's say we don't know the hypotenuse. You could always figure out the hypotenuse, couldn't you? But let's just pretend we don't know it and we're not going to use it. So if I wanted to solve for angle A right here, I want to find out how many degrees angle A is. I've got a couple options, don't I? I'm using this angle. I've got this side right here, and I've got this side right here. Actually, I only have one option if I'm going to do angle A. So what is this side to angle A? It's opposite. What is this side to angle A? It's adjacent. So which trig function uses opposite and adjacent? The tangent. So that's how we know which trig function to use depending on the numbers that they give us. Does that make sense? Saw a few people with their eyes wandering. You really got to pay attention to this. This is a big deal right here. Okay, this is because this is a question kids ask me all the time. After I've taught this for several days and we've gone over it and things like that, people say, "Well, I still don't know how. I don't know how you got tangent. Why didn't you use sine? Why didn't you use cosine?" Well, you use tangent because this is opposite. This is adjacent. It's the only two sides that you know, right? So you look up here. Can I use sine? No, because it's got hypotenuse. I don't know the hypotenuse. Can you use cosine? Nope. Can't use that because it's got hypotenuse. I don't know the hypotenuse. Can I use tangent? Absolutely, because I've got opposite and adjacent. So here's how I set it up. I take the tangent of angle A, and I set it equal to the opposite over the adjacent, which is 12 over 5. Everybody see that? All right. Now, this right here is going to tell me something. I can actually solve for angle A if I have it set up like this. And you're going to use a calculator. You're going to get angle A by itself. Now let me show you something. You'll see this on your calculator. I'll show you in a second. But this is, I don't want to just say, okay, you just put it into your calculator. I want to show you why you put it into your calculator. Are you almost ready? Or? Okay, you seem pretty busy there. All right, so I want to solve for angle A. So I want to get rid of the tangent, don't I? Now, the tangent is just a word that describes a certain relationship between a couple sides of your right triangle. It's not a variable. Everybody understand that? It's not a number. You can't divide by a tangent. You hear what I just said? Okay, what I'm saying is pretty profound because a lot of students think, oh, divide by tangent. No, you can't do that. Tangent is not a variable. I can't divide by the tangent, but I can get rid of the tangent. Remember in algebra, how do you get rid of something? You always do the opposite, or you do the inverse, right? Good. You do the inverse. So what we're going to do is we're not really going to divide by the tangent because it's not being multiplied. It's a function. It's saying take the tangent of angle A, but we can take the inverse of the tangent. Now let's go back again. I don't know if you remember this from Algebra 1. I think you might have been taught this. Were you taught how to take things to like the negative exponent? Remember doing this? Okay. If you take something to the negative first power, you're actually taking the inverse or the reciprocal of it. Do you remember that at all? So you take this, you flip it to the bottom. If you flip it to the bottom, you change the sign, and what's left on top? A 1. So 4 to the negative first is the same thing as 1 over 4. So what did you just do to that 4? You took the what of it? The inverse. So what do you do when you take something to the negative first power? You're taking the inverse of it. All right? That's the only reason I went to this, because I want you to see that you probably have seen this before in Algebra 1. Some Algebra 1 teachers don't teach it, but you guys probably did. Between Mrs. Williams and Mrs. Swam, you probably saw this, okay? So this is the inverse of this number right here. So what we're going to do is we're going to take the inverse of this tangent. Now, whenever I take the inverse of something, it cancels it out, doesn't it? All right, so if I take the inverse of the tangent, it'll cancel that tangent. But what do I have to do to the other side? If I take the inverse tangent on the left side, I'm going to also have to do what? Take the inverse tangent of the other side. So this is what we get. We get A equals. Now, how do we show the inverse? We take it to the what? Negative first. So watch what I'm going to do over here. I'm going to take this tangent to the negative first. So I take the inverse tangent of this other side. Well, 12 over 5 is still over there. So I keep it 12 over 5. That's kind of a little bit of a long explanation just to show you this. I think it's important for you to understand where this notation comes from. All right? Some teachers might say, this is how you do it, and just do it. But this is what you're going to see in your calculator. Okay? You're going to see something that looks just like this in your calculator. Did you notice that? Look at your tangent button. Who's got a calculator up? Look at your tangent button and look at, it's It's on the calculator itself. It's the second function, right? Right? It says tan to the negative first, doesn't it? Why does it say that? Because that's the inverse tangent. So, what do you do on your calculator to apply the tan to the negative first? You take the second function of it, all right? So now we're ready to plug this into a calculator. And I really want you to kind of get used to writing it like this, all right? I think it's important to see it written like this. So how do we do this? Now, it depends on your calculator. Now, if you have a graphing calculator, let me see yours, or if you have a calculator that has a couple lines on there like this is not really a graphing calculator, but if you have a calculator that looks like this with like 2 or 3 lines on it, this is how you're going to do it, okay? Now, if you have a TI 30XA, which a lot of you guys have, you have to do things a little differently, all right? But I'll show you how to do it on both of them. Now, I only have this on my little program here. I could never find a TI 30XA. I don't think they make one for the computer, but let's just do this. So what I'm going to do is I'm going to hit second function tangent. See what it does? When I hit second function tangent, it automatically makes it to the negative first. Do you understand why I think it's important? Yeah. Of what? 12 over 5. So what do I put? 12 over means what? Divide by 5. Now you don't have to close the parentheses. I know I like to keep it all nice and neat. Okay, I don't know why. But now if I hit enter, I should get, oops, you know what? Right before I hit that, I think I forgot something. Watch this. You got to make sure your calculator is in the right mode. And I think you go to mode. Yeah, see on mode, it's got all this stuff right here. I think your calculator automatically defaults. See where it says radian and degree? Mine is highlighted at radian. I have to have it in degrees for this to work. Okay. Now your TI 30XA probably already defaults to degrees. Do you see the little DEG in the corner somewhere of your? Yeah. So you're okay. But watch what I'm going to do. I'm going to scroll over here. I'm going to hit this. I'm going to hit enter. And now it's in degrees. So let's try this again. Okay. So now that was in radians. Now we won't talk about it in here. In Algebra 2, you'll talk about radians, not in geometry. And that's a pretty important thing. So that's really not my answer. Watch what my answer is going to be. Because it's going to be an angle. And does that really look like it's going to be a 1-degree angle? No, not at all. Okay, even if that's 5 and that's 12, there's no way that's going to be a 1-degree angle. All right, so I knew I did something wrong as soon as I saw that. So it's in degrees now, and now I can go ahead and do this. Do the same exact thing. Second function tangent of 12 divided by 5. Right? Looks exactly the same, doesn't it? But now my calculator is in degrees, and that's what I want to do. Don't even worry about radians right now, okay? That's Algebra 2 topic. But now I've got 12 over 5, and then hit it. Look at that. Now that looks a little bit more accurate, doesn't it? 67 point, we'll say 4 degrees, all right? 67, right, because you got to do it a little differently, right? Now, on your calculator, I'm going to show you. I said I was going to show you how to do it both ways. All right, so that would be the degree for this angle A. I just found out how many degrees angle A is by using my trig functions. Now watch, if you have a TI 30XA, I think, who's got one of those? Okay, this is what you do. You hit 12 divided by 5 first. Everybody do that. Hit 12 divided by 5, hit equals. All right, make sure you hit equals, and you get some number, like 2 point something, right? What is it? Okay, and then once you have that number, then you hit second function, then tangent, and you should get your answer. You should get 67.38, blah, blah, blah. Right? Yep, you'll get the same exact number as I have right there. All right, so now round it to a decimal. Okay, round it to 1 decimal, just to be consistent. Everybody understand that? So if you have a regular calculator, whatever you want to call it, a regular scientific calculator, you do this division first. Hit 12 divided by 5 first, then you hit second function tangent. You don't even have to hit equals. Your answer will come up right away. And what did you just get? You got what angle A is equal to. So angle A is equal, actually I should put approximately, because it's not exactly, 67.4 degrees. Does that make sense? Watch this. This is kind of interesting. Remember, I erased it. Remember I said the cosine of A is the same thing as the sine of B? Remember that? Well, let's see if that actually works. Look at this. Let's not do A. Well, that's not what I wanted to say. Wait a minute, let me think what I just said. Yeah, you'll still get the same fraction, but you'll still get, watch this. So if I said, I forget what I just said. I don't know what I was thinking. That's good enough to find angle A. Now, how could you find angle B? You can find angle B very easily without any more trig. Subtract it from 90, that's right. Okay, because remember, these two add up to 90, don't they? They're acute angles of a right triangle, so they add up to 90 degrees. Or you could do it another way.
Can you now do one where you have to find one of the sides that they only give you?
Yeah, we'll do that in a second. Okay, but let's just do this one right now. This is actually a little harder than the sides. The sides are actually a little easier when they give you an angle. So I actually started off with one that's a little bit more difficult. But let's solve for angle B not by subtracting from 90. You could do that, and it would be perfectly fine. Okay, but let's do some trig. And since Dominique said she doesn't like me writing in the same color, I'll change colors. Okay, so let's solve for angle B. And here's the two sides you know. You know this and you know this. So which trig function are you going to use if you want to solve for angle B? What is this to angle B? 5? It's opposite, and 12 is adjacent. So which trig function uses opposite and adjacent? It's still the tangent, isn't it? And you're like, well, yeah, but I'm going to get the same thing if I do the tangent of that. But look at what you're taking the tangent of. Watch. The tangent of angle B is equal to what? Opposite over adjacent, which is 5 over 12. Remember seeing that little, I don't know what I'm thinking of. What's the word I'm thinking of? I don't know. My mind just goes blank. It's Friday, it's afternoon, it's almost school's out, so maybe that's why. I'll blame it on that. So anyway, but remember I had that listing of things right here, that relationship, that's probably what I was thinking of. So the tangent of B is 5 over 12. Now, we're ready to actually put that into a calculator, but I like to do this though. I like to get B by itself. I think this is kind of important to do. You don't have to, but I think it's valuable. If I want to get B by itself, what do? Take the inverse tangent of both sides. So I'm going to get the inverse tangent of what? 5 over 12. You see that? And that's exactly what I'm going to put in my calculator. And that's why I like to write it like this. So I put 5 over 12. Oh, sorry, I was thinking of the other calculator. On this calculator, I hit second function tangent first. And then this time I put 5 over 12, not 12 over 5. 5 over 12, and look what I get, 22.6. Is that what I should have gotten if I took it away from 90? Absolutely. So angle B is 22.6 degrees. You all right with that? See, if I would have just gone 90 minus 67.4, I would have gotten that as well. Right? Either way, I still get it. Make sense? Yeah, pretty easy, huh? So it's really convenient. The trig stuff is really, really helpful. I mean, before you learn the trig, there's no way you could have found either one of those angles, right? If all you knew was just that was a right angle and you knew a couple sides, there was no way you could find either one of those angles. You could always find the third side. How do you find the third side if I know two sides of a right triangle? Pythagorean theorem. So, and knowing the Pythagorean triple, right, I just picked that to make it nice and easy. 5, 12, what? 13. Right, so now look, you solve for everything in here. What was this, 22.6? All right, so now you solve for everything on this right triangle. And the only thing that you knew to begin with were just two sides. Now you got two angles and a third side.
What would you do if you're trying to find the inverse tangent of like a square root over a square root? Like it's like remember 40 and 41, you have like that hypotenuse is like 7 square root of 2 and adjacent is like 3 square root of 2. How would you like,
all right.
How would you do
Would you just take the square root of 2 and then times it by 3?
Yeah, it's just a matter of putting it in the calculator. I'll show
Mr.
you.
Hammer, can I ask you to please send Gabby Donovan to the office for an early dismissal?
Okay.
Thank you.
Alright, so this is what we have. This is 3 square root of 2, and this is 7 square root of 2, right? And you want to find t, which is this top one up here. T. So, what do you got? You got adjacent and hypotenuse, right? Adjacent and hypotenuse is what? How about cosine?
Sine.
Cosine, right?
It's the
TOA.
same homework.
Yeah, it's the same homework. Yep. Right. So C-A-H, TOA. Right. So adjacent hypotenuse is cosine. So what do? We take it's cosine, right? So it's the cosine of angle T equals what? Adjacent, 3 square root of 2, over hypotenuse, which is 7 square root of 2. Look, you don't even have to put square roots in your calculator because you can simplify this. Bang, bang. Absolutely. They just cancel each other out. So it's just 3 over 7. All right. So T is equal to the inverse cosine of 3 over 7. And that's what you're putting in your calculator. Make sense? So I hit second function cosine, and then 3 divided by 7. Now again, if you have one of those regular scientific calculators, you would hit 3 over 7 equals, then hit second function cosine. So make sure you know how to operate your calculator. And if you have a quiz or a test, don't borrow somebody else's calculator that's different from yours, because you get used to doing a certain way. Somebody else might use a calculator that looks a little different. Crystal, let me see your calculator. On this calculator, see how it has like 2 lines right there? Yeah, if you have one like this is a TI-30X 2S, Roman numeral 2S. If you have one that looks like this, it's kind of blue. The XX, what do you call it? TI-30X XA, right? 30XA is it's kind of gray looking. This one is blue looking. Okay, kind of looks the same in the dark, but if you turn the lights on, this is more blue. This one you do like we're doing right here on this graphing calculator. All right, so you need to learn your calculator and how your calculator works. And then you hit that and 64.6 degrees, and that's what that angle right here would be. 64.6 degrees. Does that make sense? All right, let's do one where they actually give you an angle this time. I think we've covered it, haven't we, with if they give you the sides? Yep, let's do one where they 64.6.
Yep.
Let's do one where they give you an angle. Let me find one in the book here. I don't want to do all your homework for you, right? So
Oh no.
I don't want to ruin the surprise. I'll do this problem. Yeah, I'll do a problem. I'm just making up one. Well, it's from the book, but it's not from one that you had to do. So this is just an example. And 52. All right, and you want to solve for x. So what do you think? Now this time you're trying to solve for a missing side, aren't you? Can you use Pythagorean theorem right away to solve for this? No, because you don't know what this is right here, do you? All right, but you can use a trig function. If you're given one angle of your right triangle, you can, and one side, you can find this side, and you can eventually find this side as well, couldn't you, if you wanted to? I'll tell you what, let's just do that for fun. We'll call that y. Is that all right? So let's do x first. So we're going to use this angle right here. You could use this angle down here if you wanted to. I don't know why you'd want to, but what would this angle be right here? You can figure this out with just a little arithmetic. 90 minus 52, which is what, 38? Yeah. So if you wanted to, you could use this angle, but why bother? I'll use the one that they give us. Now look at what they give you and what you're trying to find. All right? They give you the 52. You're trying to find this, and they give you this. So those are my two sides I'm working with right here. So this 52 degrees, what is x to this 52 degrees?
Opposite.
It's opposite. What is this 13 to this 52 degrees? It's adjacent. So which trig function uses opposite and adjacent?
Sine.
The sine, right. Now that's all right. You can go through the so, ka, toa thing, but it's sine. But it's the sine of what? Of an angle that I actually know. What is the angle?
Please excuse the golf team
52
at
degrees.
this time. Thank you.
All right. So this is the sine of 52 degrees. On the other problem, this was A, wasn't it? Or B, or T, or whatever it was. All right. This time we actually know the angle. But we still take the sine of the angle equals the opposite over the adjacent. So opposite over the adjacent. That's how I knew to use sine. What's that? Absolutely it is, and I'm completely wrong. It's not hypotenuse. You let me go on all that time? It's the tangent. And hopefully I would have caught that. I don't know. I was going on a roll, wasn't I? And I was just saying sine. But it's what is it? It's
Seems like
opposite
so, like, would
over
be
adjacent. You're the one. I'll blame you. You're the one that told me sine.
not.
I'm only kidding. That's my fault. I should have known better. So it's
Being a
opposite.
child.
Shh, listen, it's opposite over adjacent. So it is tangent. Thank you. Now, what do? We got to solve for x, don't we? So all we do is just a little bit of algebra. You could cross multiply, but I'm not going to do that. Watch. X is on the top. How do I get rid of this 13? Multiply both sides by 13. So it gets rid of it here. Over here, I put it right out in front. That's the best way to write it. Everybody see that? And I'm ready to go. I'm ready for my calculator. So I'm going to take this and put that into my calculator. Now again, it depends what calculator you're using. On this type of calculator, this is what you're going to do. You're going to put it in exactly the way it looks right here. You're not even going to put times or anything. You're just going to hit 13. Then you're going to hit tangent. Don't hit second function, right? Because you're taking the tangent of an angle. The 52. And now you hit enter, and there it is, 16.6. So x, because I have to get x by itself. It's just basic algebra, right? So what did I say it was? 16.6.
I think
Will it
it's
be that specific? What do you mean?
13. I think
You
you
should
take
be-
the tangent on this calculator. You take the tangent of 52 times
Right.
15.
You should be
Yeah, that's
really
what you
close.
do.
I mean, you should get this.
You take the tangent of the angle
Right.
on this calculator.
So you
and
should
then
get
times it by
this. I mean, if you're doing it right, you shouldn't be off by even a few decimals. I mean, you should be right on.
52 tangent.
So, like Caitlin said, if you're using the scientific, the TI-30XA, okay, you don't go 13 tangent 52 because what that would do, it would actually be taking the tangent of 13, wouldn't it?
Yeah.
Okay, so you hit 52 first, then you hit the tangent. Okay, you put the number in, then you hit the function.
Then
Whereas
times 13.
this calculator right here, you hit the function first, then the number. All right. I grew up in college and everything, using a calculator like you guys, like the regular scientific. So I'm actually a little more used to that. But that's what you do. You hit 52, then tangent. That'll give you some decimal number, right? Then you multiply it by 13. So then you hit times 13. And everybody, no matter what calculator you're using, if you round it to the tenths place, everybody should get that answer right there. Am I right on that? Okay, make sure you're practicing using your calculator. Like a lot of people say, well, I love my calculator, but sometimes you got to learn how to use it. It's not always as easy as putting, 1 plus 5 or something like that. Okay, you got to know how to use it. What's that?
Use the angle
The
they give
opposite.
you.
Exactly. I use the angle that they give me. Okay, I could have used this one if I wanted to, but I just use this one, the one that they give me, and then I look at the two sides, right? One I don't know, but one I do know, but then I look at them. This is opposite, this is adjacent. That means I use tangent. That's why I use tangent. Yes. Let's do y. Yeah, let's do y. So this is 16.6 for x. Now, you could use Pythagorean theorem, but if you use Pythagorean theorem, remember, this is an approximation, isn't it? This isn't exactly 16.6. So when you take an approximation and square it, it becomes even more of an approximation. Does that make sense to you? All right, so what I'm going to do is I'm just going to use a trig function to solve for y. All right, let's not use the 16. Let's just pretend that we didn't know this was 16.6. Let's solve for y from scratch. Is that all right? So let's do that. Let's use the same angle. So 52. Now, what is 13 and what is y? 13 is, y is hypotenuse, and this is adjacent. So what is adjacent and hypotenuse?
Cosine.
Right. Adjacent and hypotenuse is cosine, isn't it? All right. I did get that right this time, right? Okay, good. So we're going to use the cosine of that angle. I picked this angle, right? So that's what I'm using. The cosine of 52 degrees is adjacent over hypotenuse, 13 over y. Now watch the math on this. I'm glad we're doing this one because the math is a little different. And this messes people up a little bit. This was pretty easy because x was already on top, wasn't it? And 13 was on the bottom. I just multiplied by 13, no big deal. But watch the math here. I have y on the bottom. Okay, I don't just get rid of the 13, do I? So what I'm going to do is this. There's a couple ways you could approach this, but this is how I look at it. I want y on the top, so how am I going to get y on the top?
Multiply by y.
Multiply both sides by y, right? Everybody see that? So I'll show you the steps. I probably wouldn't normally write that in there. I would just do this. So I multiplied by y, that canceled out, I got a y over here. You with me? Now what do I want to get rid of? The cosine of 52. Now a lot of people think they're two separate things, but they're not. They're related to each other, right? It's a function of 52. So it's just a number. If I put the cosine of 52 in a calculator, it's just a decimal number. So this is just a regular number. How can I get rid of a regular number?
Divide
I just divide. Okay, this is not where we do the inverse because I'm not trying to get an angle by itself. All right?
Could we?
This cosine of 52 is just a regular number. I mean, it's a little weird number because it's a decimal, but watch. The cosine of 52 is just a number. See that? 0.61566. Okay, that's just a regular number. How do I get rid of a regular number if it's being multiplied? I divide it, right? So what am I going to get? I'm going to get y equals what? 13 over, now don't even put the decimal in here. Actually write the cosine of 52. Well, you got to put, now you put it in the calculator. Okay? But don't put it in here first and then move it over. All right? Because then you're going to divide an approximation. Don't want to do that. All right? So this is what I'm going to put into my calculator. So that's where it gets a little tricky. That's probably the hardest one that students have trouble with. Okay? Right. So on this problem, I would go 13, on this calculator, I would go 13 divided by the cosine of 52. Everybody see that? And then I get about 21.1.
That's it.
Okay. And that's what this is. Now, always look at your answers to see if it makes sense. This is 13, this is 16.6, this is 21.1. Does it make sense that those numbers are where they are? Yeah, because 21.1 makes sense because it's the what? Hypotenuse, and the hypotenuse always has to be the largest side, doesn't it? All right? Does that make sense? And look at the angles. 52 is bigger than 38. So look, 16.6 is bigger than 13. Right? There's a lot of little checks that you can do just to make sure you did it right. You just didn't, push a wrong button on your calculator. Because people will do that. People push a wrong button on the calculator and just put some crazy, ridiculous number in for this when they haven't even considered, does it make any sense? So make sure you do that. Make sure you just take a quick little look and say, does everything make sense? Is the hypotenuse the longest side? Is the side opposite the smaller angle the smallest side? Yeah. If it is, you're probably right. Okay, you probably did it correctly. All right. I don't want to do too many from the book because it'll spoil all the fun. 31, is that what you said? All right. And square root. All right, so let's do this one. And I think we've covered them all. After I do this, I think we've hit everything. So this is 15 square root of 3. This is 63 degrees. This is x. All right. So we're going to use this angle, right? Because that's the one they give us. Might as well just use the one they give us. And look at the two sides in reference to this angle. So what is this side to this angle? Adjacent. What is this side? Hypotenuse. We just did one, so it's the cosine. So it's the cosine of 63 equals the adjacent, 15 squared of 3, over x. Now watch. After, you know how I did all this work and I showed that it multiplied and I divided it. Basically, what did we just end up doing? I just switched places, didn't I? I took the cosine of 52, stuck it on the bottom, took the y and stuck it on top. All right? If you realize that's what you did, that's what we're going to do here. So what are we going to do? Switch these two, right? Take the bottom, put it on the top. Take this one that's on the top, put it on the bottom. So what's x equal to? 15 squared of 3 over, exactly. And now it's just calculator work. Now here's what you would do. Here's step by step if you're using one of the not graphing, the scientific calculators, TI-30. Okay, so this is what you do. I would just go 15 times, do it, 3 square root hit equals. All right, that gives you what that is equal to. Then you hit divide,
Square root.
and then you hit 63, then cosine. So that number you're looking at right now is the cosine of 63. How do I do the divide? I have to hit equals, and I got the whole thing. Is that what it is? 57.2? Okay. Now, if you have this calculator, it's a little more straightforward. All right, you would just hit 15, and then the square root of 3, right? And then you take that whole thing and divide it by the cosine of 63, right? It's just exactly the way it looks right here on this type of calculator, and you get the same thing, okay? Same decimals and everything, right? Okay. Make sense? 57.2. Technically, it's approximately, but, you know, I'm fine. All right. So what do you think of that trig stuff? That's pretty good, isn't it? Yeah, it's not too bad. I mean, when you first look at it, you're like, oh, my goodness, I'll never be able to do trig. And just the word trigonometry is kind of scary, isn't it?
Oh, is that what you were meaning by trig?
Trigonometry,
I thought
yeah.
when you said trig, you meant like trig.
Well, trig, we say trig because it's just short for trigonometry. And so people that are cool say, I'm going to do some trig instead of trigonometry.
Oh, yeah. That's
Right?
really cool.
That's right. Cool people like me say, that's right, Sokotoa. That's right. I want to hear it. Nobody's told me Sokotoa yet. So,
Mr. Hammer.
why not? That'd be so awesome. You can start a new trend. Sokotoa and high five them. Come on. I'm going to do that to you guys sometime in the hallways. Yeah, that's right. That's right. That's where it starts. It starts with the lower grades, and then the upper grades say, wow, look how cool they are. I want to be like them.
Oh, yeah.
All right. All right, no silliness. So you're going to finish up that homework, right? Finish up that homework that I gave you yesterday. What were the numbers, just so I can write it down?
22 to 41.
To 41. Okay, and then it's section, what was it, 8-4? Okay. All right, so finish that up. We'll collect that on Monday. Then we'll move on from there. Remember, next week is the last week of the marking period, okay? Just so you remember. We could probably squeeze in a quiz, but we won't have a major test, no.